Okay, chapter 10.4. Remember, like terms are terms that have the exact same variable parts. Okay, when you're adding or subtracting numbers, what do we do when something is missing? Now, I'm doing this to show you how this next thing applies to something you already know. Okay? So we take 4.7902, and remember, when we have decimals, we stack the decimals. So 3.8, and you could put 0, 0, and 0 underneath the rest of it. So 2 plus nothing is 2, nothing plus nothing is 0, 9 plus nothing is 9, 7 plus 8 is 15. So we bring our 5 down, and we carry the 1. Notice our decimals all stacked up. So 1 plus 4 is 5, plus 3 is 8. Okay. Well, in this case, it wasn't absolutely necessary to have the zeros. But in this case, we absolutely must have them. And remember, if I don't see a decimal, the decimal goes at the end of the number. So minus 9.0037. We have to have zeros up top here. And we can't subtract 0 minus 7. So we have to steal from the 7. That makes it a 6. Give it to the 0, so that's 10. Got to steal from there, that's 9. Give, steal, 9, give, steal, 9, give. We don't steal once we get to the end here. 10 minus 7 is 3. 9 minus 3 I can do, so that's 6. 9 minus nothing is 9. 9 minus nothing is 9. 6 minus 9, well, I can't do that. So that's a 4, and that's a 16. 16 minus 9 is 7, and we bring a 4 down. Well, guess what? We're going to do this same kind of idea with polynomials. We look, we've got a 7, a 4, a 2, a 1, and technically a 0. Our highest degree. So write the polynomial in descending order, no missing terms. So I have to have an x to the 7, x to the 6, x to the 5, x to the 4, x to the 3, x to the 2, x, and our constant. Now the number in front of x to the 7 is 1. We don't have an x to the 6 or an x to the 5, so we say plus none of them, because 0 times x to the 6 is 0. And 0 times x to the 5 is 0. So I haven't changed this by putting those in there. And then plus 31, x to the 4th. We don't have an x to the 3rd. We have a negative 17, x to the 2, and a plus 5x, and a minus 21. So this polynomial is the exact same thing as this. It just looks differently. So what about this one? Descending order, by the way, means these numbers are descending from the highest one down. So the highest one here is x to the 3rd. So we have to have x to the 3rd, x squared, x, and our constant. We have the x cubed, we have our constant. We don't have an x squared, we don't have an x. Now, we've been adding like terms since Math 55. And you're going to hear this over and over and over, because it's true. You've been doing this stuff for a while now. Now, adding polynomials. Stack your like terms, kind of like when you stacked your decimals. You had to stack your like decimal place values. Okay, well here you stack your like terms, and then technically you add. Well, sometimes you have to subtract because one of them's a minus. But remember, if both are plus, both are positive, or both are negative, you have to add them and keep your sign. Subtracting polynomials. Change all signs from the minus to the right, and then technically you got the other rule, you add them. So here you got a plus in the middle, so all you do is you stack your like terms. So 7x squared minus 3x squared, 7x squared, 3x squared, plus 2x, plus no x's, because there isn't an x by itself, minus 9, plus 5. So 7 minus 3 leaves us 4. And notice, when I count my horses, I keep my horse the same. I do not genetically alter my horse when I count them. 2 plus none is plus 2, and again, I leave my horse the same. Now, if I owe 9 and I pay 5, I still owe 4. Hey, and again, I got a plus, so this is a good thing. X cubed, x constant. X cubed, x squared. No x, but a constant. So, 1.2x cubed plus no x squared minus 3.4x minus 7.9. Notice, no x squared, but I put that place value in there because I need it for this problem. So, 6.7x cubed plus 4.4x squared plus no x's minus 10.9. And I'm going to use Mr. Goodbuddy calculator. Okay? Here we go. I need to put it, okay. Here we go. Second quit to get back to a normal screen. 1.2 plus 6.7 gives us 7.9, and again, count on my horses. Don't genetically alter them. And nothing plus 4.4 is 4.4. X squared, and negative 3.4 plus 0 is negative 3.4 x's. Now, negative 7.9 minus 10.9 gives us negative 18.8. If you have questions, just ask. Now with this problem, it looks really horrendous. But first, let's deal with this. This is subtract. So, remember, I said change all of my signs. So chop, 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 chop. So this became plus, this became minus, plus, plus. Remember, change your signs first. Now, I'm just going to rewrite this real quick. Negative 4 over 7 plus 3 over 7 n squared. And I'm just going to say plus 5 over 6 plus 5 over 12 m. And I'm going to say plus here. Negative 1 over 20 plus 3 over 10. And now I'm going to use Goodbuddy calculator. Negative 4 divides 7 plus 3 divides 7 gives negative point yuck. So math, I'm showing you how to cheat now. Enter gives us negative 1/7 n squared, and then 5 divide 6 plus 5 divide 12, enter, 1.25, but they're going to want the fraction, so math, enter, enter, is plus 5 over 4m. Now negative 1 divide 20 plus 3 divide 10 is 0.25. Math, enter, enter. So plus 1/4. Now ain't that a hairy bunch of mess? But using that shortcut makes this a whole lot nicer. Now this problem here looks pretty yucky too, but remember, chop, 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 scribble, chop. Alright, now I've got, and I'm going to take my longest part of this, so 5a squared plus 7a minus 4. This says minus a squared, so minus 1a squared, and then plus 1, plus no a's, and this says plus 1a squared, plus no a's, and minus 3. So, he who subtracted it also added it back, so that went away. So 5a squared, and 7 plus nothing is still 7. Alright, and I'm just going to use the Good Buddy calculator real quick. Negative 4 plus 1 minus 3 gives us negative 6. So we say minus 6. Whew. We're close to done. 4x subtracted from is a big fat hairy deal, and this wording is never ever going away, so learn to become friends with it. If you don't, it will keep biting you in your behinder parts. Subtracted from means you get this first, so 7x minus 3, then minus 4x. And this has an x, and this has an x, and there's no equals to take them across, so all we have to do is combine them. 7 minus 4 leaves us positive 3x, but we still have our minus 3. And remember, this is a QIYD problem because it doesn't look like an answer, but it really is. So quit idiot, you're done, because this really is your answer. I just want to make a little note here. You will have surprises with this in my math lab, like applying this information to different polygons, so get ready. And what I mean by that is like this. If this is 3x plus 4, and this is 2x plus 1, find the perimeter. Well, remember, perimeter is all four sides. So if this is 3x plus 4, this is also 3x plus 4. If this is 2x plus 1, this is also 2x plus 1. So we get 2x plus 2x plus 3x plus 3x plus 4 plus 4 plus 1 plus 1, and I'm running out of room, but that's 4, 5, 6, 7, 8, 9, 10. 10 x's plus, that's 8, 9, oh, that's cool, also 10. Okay? So, these kind of problems will be there, not only for perimeter, but also for area. So get ready for this.